In this lesson, we shall solve this particular geometry question, and we shall spend time looking at how best geometry questions of this nature can be done, but also geometry questions that pertain circles and chords, okay, and tangents as well. And we shall actually proceed. For instance, in the sketch below, PQRS is a cyclic quadrilateral. So this PQRS is a cyclic quadrilateral. And right, so we have line AB is a tangent to the circle at point S. So line AB is a tangent to the circle at point S. Yeah, it is a tangent point S. PQ equals QR. PQ equals QR. PR is SR. PR is SR. PQ is SR. PQ is right. Is parallel to SR. Okay, we have parallel sides there. Like BSR, the angle BSR is X. Right, this angle BSR, this angle here is X. Is X. Determine giving reasons 5 angles that are equal to BSR. Okay, so there are 5 angles that are equal to BSR. In other words, there are 5 angles that are equal to X. And let us spend some time on that and analyze these here. Okay, yeah, there are more questions I would have loved to do here, but let's see how well we can actually proceed to solve these particular problems here today. Right, so we continue to solve these particular questions here. Okay, now there's the Tenko theorem that says the angle between the tangent to a circle and the chord equals the one in the alternate segment. So now there's an angle subtended by this chord. This chord subtends an angle here. So this chord here subtends an angle. So this angle is also X. So we can also say the angle P2, for example, is X. Why? Because of the Tenko theorem. Next question. Right, so in the next question, we shall look at the fact that, so this is the tangent, right? So it's going to be the tangent AB, tangent AB, chord, tangent AB and chord SR. Okay, so obviously you can see that there's an angle between the tangent to a second chord equals the one in the alternate segment. Now, next, okay, this one is already is X already. But what else can we actually be able to deduce at this point? Anything else that we can deduce? Like, we can analyze some of these, like PQ equals QR. If PQ equals QR, what else are we able to see there? But also, if PR is equal to SR, okay? So this is equal to this. So this triangle is called isosceles, so that now the base angles are equal. So this is X. So we have also that the angle S2 equals X. Why? We then say that you can say PR is equal to SR there, okay? And PR equals SR given. Or you can say, at this point, you can say the angles opposite equal sides. So angles opposite equal sides are themselves equal, right? So angles opposite equal sides are themselves equal, so that indeed you have that. Okay, this was just, it went off because of the thing, because of the recording of the previous discussion. Okay, now that is something that is therefore very important there. We continue. We continue. Right, so we are looking at 3.4.2. Right, so Okay, we're saying S2 is also X, and we say angles opposite equal sides. Okay, very popular to say angles opposite equal sides. Okay, right. So what else are we able to deduce here? The angle P1, is equal to X. Okay, we know that the angle P1 equals X. Why? You see, the angle P1 equals X because you already know that this one is parallel to this one and this. So P1 equals X. Those are alternate angles. Alternate angles because APQ is parallel to SR. APQ is parallel to SR. Okay, this is parallel to this. So we have alternate angles in Z. But also the angle QRS. The angle QRS. The angle QRS is X. The angle QRS is X. Right, because of the exterior angle. This is equal to this. Okay, there's a theorem about the exterior angle of a cyclic quad. Okay, so if you have this, something like that, this angle here is equal to this angle here, and this angle here equals this angle here. So the exterior angle of a cyclic quad equals the interior opposite angle. So exterior angle of cyclic quad. Exterior angle of cyclic quad. So the exterior angle of cyclic quad equals the interior opposite angle. So once again, if you have this, is the theorem that says it did not go through the other side, but what is very important is therefore if you have this, right? So this is a bit too high. Let me lower it a little bit just to demonstrate the power of the theorem here. So you have this here, you have this, you have this here, and you have this. So this angle here is equal to this angle. So the exterior angle of a cyclic quad equals the interior opposite angle. Okay, so that this angle X is equal to this one here. Next, the angle A is also X. This angle is also X because if you, this is parallel to this, the angles, if this is parallel to this, then this angle equals this, and those are called corresponding angles. So corresponding angles, APQ is parallel to SR. Okay, so we found 1, 2, 3, 4, 5. We've given 5 angles that are equal to angle BSR, and angle BSR is X. Next question. 3.5.2, want to calculate the value of S1 in terms of X, S1 in terms of X, as well as the value of 2 other angles that are equal to S1. Right, let us find this. Sorry, yeah, the couple of things we found. This one is X. We found this one is X. We found that one is X. Right, so we found lots of the X angles. Found lots of the X angles. Okay, so we found this one is X. See what else we've been able to get here. XX, see if we have labeled X, and also this one is X because of the base angles. Let's see what else. This X here. Right, so we've seen before that if that is the case here, you have therefore that the P1 is X, and then the P2 is X. Right, so you have exactly that there, and that is as well X. Okay, right. So now we need to find therefore the angle S1 in terms of X. So the angle S1 in terms of X is very easy because these are adjacent angles on a straight line. So to find the angle S1 in terms of X, as well as the value of two other angles that are equal to S1. Right, so obviously this is this plus that plus that. So we have S1 plus S2 plus S3 is equal to 180 degrees. And these are angles on a straight line. Right, so these should be angles on straight line. Okay, so yeah, it's S1, S2, S3. So you have S1 plus, what is S2? S2 is X plus X, which is 180 degrees minus 2X. So yeah, this S1 is actually 180 degrees minus 2X. So calculate the value of S1 in terms of X, as well as the value of two other angles that are equal to S1. So what would this is a tangent, so the angle subtended by this chord, and this chord subtends the angle R1. So immediately we're able to see that the angle R1 is actually equal to S1. So we're able to see that the angle R1 is S1, and it is the Turncoat theorem. Goodness me. Okay. So R1 is S1. Okay. What else are we able to achieve? Because obviously this one is doing this. So there's P3. So also angle P3 is equals to the angle S1. Why? They're alternate angles. Why? Because AQ is parallel to SR. Okay. Okay, we'd have a lot of that. Okay. Oh, what else? So yeah, we found two other angles. So R1 and P3 that are both equal to S1. So we found two other angles equal to S1. Then the last question is prove that PS is equal to QR. Prove that PS is QR. Prove that PS is QR. Prove that PS is QR. Obviously, I mean, to prove that PS is QR, the couple of things we need to consider here at this point. So we know that the angle R1 is equal to the angle P3. The angle R1 is equals to the angle P3. And why is the angle R1 equals the angle P3? Obviously, there are alternate angles there. They are alternate angles because of the parallel lines. So these are alternate angles because PQ is parallel to SR, and this is given. Okay, if angle R1 is equal to P3, okay, the alternate angles, this is parallel to this. Okay. We have PS. PS is equal to QR. We have PS is equal to QR. Okay, if we're able to see that therefore this is equal to this, then we can be able to see that PS is equal to QR. So this is true because equal angles subtend equal chords. Equal angles subtend equal chords. Now let's look at this, and there are many ways to prove this, but equal angles subtend equal chords. Okay, yeah, this would be true at this point about these cyclic quads here. This would be true at this point about the cyclic quad. That so yeah, you have done some questions on this, but also I mean there are some results you need to know about the cyclic quads, that the opposite angles of a cyclic quad are supplementary. So if this is a cyclic quad like this, then the opposite angles are supplementary, so that if you have a cyclic quad like this, you have PQRS, you would have that angle P plus angle R is 180 degrees. And these are the opposite angles of cyclic quad, and obviously the opposite angles of cyclic quad are themselves supplementary there. And obviously we have the exterior angle, like in this case, you have this and this and that. So this angle is equal to this angle here. The exterior angle equals the interior opposite angle. Okay. Yeah, any question? I would like to do more, but yeah, I'm sure that we'll spare time, we'll get time and do more of this. And practice more, because the best way to do this is to do exam questions, past questions, and you can see exactly how these things are asked. We need to just spend a bit more time, because this would be, see, this was the end of the paper. That's the end of the paper where these things were said. But I would have obviously like to do more, but we shall make time available and do more and more of these to make sure you can practice these, because they can be a little bit tricky, but they're not only that grade 11, but they're also that metric. Okay. Any question, Tando?
I know, sir. I think I'm good.
Yeah, definitely. Yeah, but we'll get more time and do like lots of exam questions. Okay. So that you can like develop the ability and the skill to solve any question. Okay. Right. Yeah. Thanks a lot, Tando. From us, it was interesting having discussion tonight. I'm gonna make these videos available on the WhatsApp groups tonight. I'm just gonna be loading them now and so on. And I'm sure that on the WhatsApp group you'll see them and you'll think about this. I wish I wanted to do a lot of paper 2 today, but yeah, this other student came to me and told me they're writing paper 1. That is why I started with paper 1, because I wanted to do a lot of geometry and other things, but the student said they were writing paper 1 tomorrow. Okay, I know that you have did paper 1 already, so I then thought, okay, we can do the paper 2 afterwards. Yeah, but yeah, anyhow, there's always a way out of the situation. I'm sure that you're gonna be fine, but yeah, we'll spend more time doing paper 2. So yeah, we'll make more time available. Okay.
Yeah, thank you.
Thanks, Tando, and have a good evening, and all the best to you for tomorrow. All the best. Okay. Thanks, Tando, and goodbye to you.
Good night, sir.
Good night, Tando.